The polar form of a complex number, example 2. We're to express -1 plus I root 3 in polar form. We might have a sketch of this first on an Argand diagram. Root 3 has the value around 1.73. So it gives a sense of where it is in the Argand diagram. So here, the real part is going to be -1, and the imaginary part is positive root 3i. Now we will see on the Argand diagram when we sketch this number has a position and a modulus, that is a radius or distance from 0, and it makes an angle with a positive sense of the real axis. We call this the modulus theta. So we want to express the number in terms of its radius and modulus. Using Pythagoras' theorem on the triangle, we could see the square on the two smaller sides are 1 and 3. So the square on the hypotenuse is 4, and if we square root this, we see 2 is the length of the modulus, using Pythagoras' theorem. We could also come up with this answer if we use the formula for modulus. So the modulus, the size of a plus bi, would be the square root of a squared plus b squared. So in this question, that's the square root of -1 squared plus the square root of 3 squared. We see here we're getting the square root of 4, which is 2, the same answer we got by solving the triangle. So the size of this number is 2, its modulus is 2. We want to work out its argument. I'm going to call this angle alpha inside the triangle. This will help us work out theta. We can see that tan of the angle alpha is root 3 over 1. That's the size of the angle alpha. So if we took out the calculator and worked out, if we didn't know it already, the size of angle alpha, because alpha must be tan inverse of root 3. And you might know already that this is 60 degrees, or in radians, which we usually use when we're dealing with complex numbers, it's the same as pi over 3. So we use this angle alpha to work out the argument theta. We can see together they must add up to a straight angle, or pi. So if we take pi over 3 from pi, we're left with 2/3 of pi, 2 pi over 3. So that's what theta is. It's 120 degrees in degrees, or 2 pi over 3. So in polar form, when we express this in terms of the argument and modulus, it's r cos theta plus I sine theta. So we write it as 2, that's what our r value is, by cosine the angle 2 pi over 3 plus I sine the angle 2 pi over 3. That's how we express a number in polar form.